Hello everyone, and welcome to a kind of unusual video. Now today I'm going to respond, not react, I've already seen the video so I know what is going to come, but I'm going to respond to this video which is called How to Try and Fix a Graphics Card Complete Start to Finish from TechYesCity. I have several issues with this video, which is why I want to respond. But first, as a disclaimer, I have to say I'm not looking for trouble here. TechYesCity, from what I've seen, like I've followed his video a bit, mostly does like used computer hardware and like getting used deals, and he seems to know his stuff there. But he has made a couple videos, including this one, where he tries to quote-unquote fix graphics cards. And he has gotten some of those working. But in those videos, specifically in this one, he does things that are just wrong and misinformation, and it will probably result in more graphics cards going into an oven than have to. So yeah, like I'm not looking for trouble here. I don't want to start any kind of beef or whatever. Like he has 500,000 subscribers. I don't. Like I obviously already lost the battle if I was looking for beef here. I just want to respond in a civil manner on what issues I have with this and what I would do instead. Like I'm not gonna claim that I know everything about repair. I've repeatedly said that repairing things is just a side effect of my hobby of buying old hardware from eBay to benchmark and overclock it, and sometimes I buy that stuff and try to repair it to like in the end get hardware cheaper. Though I have a certain knowledge of repairs, it's not very extensive, it is rather basic, but it is good enough to tell that what's going on in this video is very, very wrong and should not be out in the world in this way. So yeah, as you can see down here, the video is about 20 minutes. I am going to stop mid-through to say things, so this video is probably going to be around 30 minutes. So yeah, let's just start the video.
With graphics card prices being ridiculous right now, I thought I'd make a video just explaining a basic how to try to get your graphics card working from start to finish. And what I got given here when I was on a used PC parts hunt was a 7770. This is an old AMD graphics card now that was released actually quite a long time ago, pretty much over a decade ago. And I was told it just didn't work. And then there's a GTX 970 here as well that I got given, and the person said it doesn't work, you can have it and try and get it working again. And so I thought to myself, why not just take you guys through the steps that I do, essentially a process of elimination to see if this graphics card has completely gone or if there's any signs of getting it to work again. And what we're gonna do straight away is start off with a graphics card and a test bed that we know that works. And this is important because then that rules out any other problems, and then we can identify that it's actually the GPU that's the problem. So let's get on with this tutorial and see if we can get two graphics cards to come back to life. Today's video is brought to you by the aswell.
Okay, that's the sponsor. Let's get to the first part. So, first important step, get a good test bed set up. Nothing wrong with that statement. Let's see what he has to say.
GPU up here, and we can see that our test bench is working absolutely fine. So this is important to make sure that if we test a graphics card going forward, that there's nothing else in the pipeline that is wrong. So now we can put our first GPU in that was given to me that was faulty to see if we can.
Okay, so yeah, his test setup is, yeah, it's pretty good. I have nothing really an issue with his test setup here. He has a motherboard with a postcode, and he has also has power and reset switches. That's very handy. You don't need to have that, but it's handy. That's nothing wrong with that. One thing that is wrong here is though, as he said in the video, he was just given the card and said it's not working. So when the card is not working, it can have pretty much any problem. And when you don't know that the problem is not gonna cause, say, a fire because there is a major short on the card, look at that foreshadowing, you do not want to turn it on. Unless you have absolute faith in your power supply that it will kick on the protection mechanism fast enough. I have a lot of faith in my test bench power supply because it repeatedly saved my cards from spontaneous VRM combustion. But if you want to do this and you don't know for a fact that your power supply has very, very fast and good protection mechanisms, don't immediately turn the card on. Tear it down, check for short circuits, and only if you find none, then you can turn it on.
Can actually get any initial signs of life out of it, and I've got a few tricks for doing this. So here's the first card here, the 7770, and we can see here by the BIOS code, we are getting to the BIOS screen. This is what the A9 means. If you don't have a BIOS code, you can use a little speaker and plug that in, and that should give you some beep codes to let you know if flat out the VGA card is failing. On this board, it'll give you a B2 error if the card itself is stopping from booting into BIOS. And now another problem we've got here is that we've tried the HDMI port, and we've tried also one little trick that I always use, and that is to try and get a VGA out on older cards. From the 10 series and onwards on NVIDIA's side, and I forgot which AMD implementation, but they did remove VGA support in the newer cards. So this trick won't work in some newer cards, but on older cards, sometimes it's only the HDMI scaler that blows out, and you can still have a signal coming out to a VGA cable, hence you've still got a usable graphics card. But in this case, we got something a little bit more wrong with this GPU, so now we're going to try the GTX 970 because the next step...
Okay, so that VGA out thing, that's fine. I have no issue with that. I've never had a card that had this issue, but if he encountered one that just had a dead HDMI port, I guess that's good for him. I can't prove that what he's saying is true, but it does make sense to me, so I don't really have to say anything about that. Now it's getting to the GTX 970, this is where I get some of my major issues.
Step involves us taking the card apart.
So, he has the 970 on a test bench now. You see he just pressed the power button and nothing happened. This is an immediate red flag. Like, I told you in the beginning, if you don't know what's wrong with the card, if you have no idea what's wrong with the card, do not turn it on. Because the card could have a short circuit, which this card has, and when you have a short circuit, there's actually, I'm pretty certain that what short circuit this card has is a short from 12 volts to Vcroe, because I actually have that card with that PCB. I have a 970 with that exact PCB, and that PCB uses some dual NFETs in its Vcroe VRM that MSI also used on other cards. And on all these cards, these dual NFETs were known for dying. So what probably happened is that one of those dual NFETs on this card died as well, which means that 12 volts is now shorted to Vcroe, which means every time you turn it on, even if it just for a millisecond the power goes in there before the power supply shuts off, your core is getting 12 volts, which is about 10 times more than what it should get, and it will very, very quickly turn into a unfixable rock. That is why you shouldn't turn it on. And it could also be another short circuit, and it could even produce a fire, it could start to smoke. It's very bad. If you have a power supply that doesn't have a good protection system, things can melt, they can catch fire. I made a video about the GTX 780 that had one of its power stages literally blow a hole into the PCB. That's what happens when your power supply is not very high quality. Mistake number 2 is he turns it on and nothing happens. The power supply clicks over current, short circuit over current protection, it clicks protection, and he turns it on again. Do not do this. Just don't. If you turn it on once, and it usually the power supply makes like a click sound, you hear that, you know, okay, there's a short. Don't turn it on. Don't do what he does. Every time you click that power button, there is a chance that goes even higher every time you click the power button that the card is dead. Now he's diagnosed the problem as a power delivery problem, which is correct. He doesn't really say in the video what exact problem is it, but as I've explained, I'm pretty sure that one of the dual end FETs in the Vcroe VRM is shorted. So his diagnosis here is correct. It's just in the rest of the video is going to deal with it in a inadequate way. And he tries to turn it on.
So this card right here, the GTX 970, we tried booting this up and the computer wouldn't even boot, meaning that there's actually a serious problem in terms of power delivery. So both these cards that we've started off this video with are now going to have to be pulled apart. Also, one more thing in terms of power delivery problems, do be careful if you have this sort of issue, especially if you see some kind of fire or weird smell coming off from the graphics card, then you may wish to just stop right there, because basically when cards have power delivery problems, like in the case of this GTX 970, it can actually end up causing problems to other parts, other PC parts, if the power supply does spike or something shorts out. So do be very careful if you know something's really off and the computer doesn't even boot up, like in this case with this GTX 970 to begin with.
So yeah, a bit of elaboration on that. Other components can be damaged. I've never had a case where it could have happened, like where it happened to me. I never heard of it happening, but when you have a short circuit somewhere, let's say somehow your 12 volts power gets short, let's say somehow your GPU core dies and you get 12 volts power shorted onto your data lines. The data lines go into the motherboard, to the CPU, and at least your CPU, and probably also the motherboard is toast after that. If something like that happens, yes, it can absolutely damage other components in theory. Never happened to me in practice, but yeah, probably true. There's probably a possibility, just like ESD killing components, even though that never happened to me in practice. And Linus and Electroboom show that's very unlikely of happening, but there is a chance.
Das ist das neue Google.
Thank you, German advertisement. Yeah, sadly we have to go through that. Let's hope this doesn't happen again. It probably will.
So now we've just taken these two graphics cards apart, and it's looking like it's at least some decent news so far, in that when I've taken these cards apart and just cleaned them down quickly with an alcohol wipe, I haven't noticed any part that looks physically damaged.
Cards don't always have to have a physically damaged part. If you have something that's already like molten down or like looks like there was a major short circuit, you're pretty much done at that point. That 780 that had a damage like that, I never ended up fixing that. And I pretty much given up on that because it turned out to be far too hard to fix. If you have other physical damage where like components are missing from the PCB, that's fixable. It is very annoying to fix, but that's fixable. But if you suspect a power delivery problem, like he's saying, and you see something damaged, it's gonna be because something has melted or something caught fire or like something else. And at that point, you already know that this card was used with a very, very cheap power supply, and it probably got way too much voltage, and I would still try to repair it, but there's a very, very slim chance of it being alive at that point.
But I did notice in the case of this GTX 970 that there's a lot of debris just floating around, and so cleaning out your graphics card can, especially in the case of this 970, I'm hopeful for it because it can be something could be shorting out and stopping the card from booting. And also on this
dust and debris on the card, theoretically, yes, they can cause problems. I would like to know how it can cause a major short circuit. So this card its power supply is tripping over current protection. It obviously has a major short somewhere, and as I said, I'm suspecting a short from 12 volts to Vcroe. Debris on the card can cause problems, but not problems like that. Problems that debris can cause is like the card is clocking weirdly, or like it's having intermittent issues, or like you have to reduce clock speed for it to be stable. Like sometimes you can have like corrosion or other things on contacts, and the signals going through those contacts are no longer as good as they have to be, and that can cause problems. I would like to know how a little bit of debris or corrosion can cause a major short, so major that the power supply has to step in and shut itself off for safety.
7770, there's no obvious signs of physical damage. So what we're going to do now is actually give it a second clean now with some multi-purpose spray. And this is essentially just going to get any extra debris off, as well as just coat some of the electronics with a protective layer. So one thing I will say though is if you're at this stage and you notice that something's obviously wrong, say for instance one of these little SMDs here is chipped off, or it looks like it's just completely rusted and corroded off, then you may have to either do two things. And that is, one, if you're really good at micro soldering and you can get a voltmeter and replace the faulty part, then you can bring that graphics card back to life. Or two, take it to an electronics store and get them to fix it for you. Now in Australia, unfortunately for these last two things we just discussed, I'm terrible at micro soldering. So that's out the window for me. If I tried to fix this thing, I'd be here for days and it just wouldn't be worth my time. And even then, there's no guarantee that it'll work again. And then for point B, fixing these cards professionally in Australia will cost a lot more than the actual card's even worth. And so with my micro soldering skills, I'm pretty much only at the level where I can solder two wires together. And some would say in the comments that, Brian, you don't even do a great job of that. But coupled with the fact that in Australia, these kinds of services do cost a lot of money, especially when these cards are out of warranty, you're kind of left at the end of the road if one of these parts is damaged. But
so he does acknowledge here the proper way to repair this, the probably only way to repair this. At least for the 970, I'm not quite sure what issue the 7770 has. I'm suspecting that one of the VRMs just doesn't work on it and it's not being properly detected. Just because the fan spins doesn't mean the card has all the power present. Like the fan usually always spins, even if the VRM's all shut down. Actually, if your fan always is 100%, it probably means the GPU core is not running. That's like a failure mode of a lot of cards. When the fan is 100% all the time, it means like the GPU core is not communicating. Yeah, so he also brings up a fair point that going to a professional repair shop is very expensive, especially for older cards. You might end up paying more than the card is worth. That's a fair point. At that point, I would probably say, like, okay, just sell it on eBay as broken, you get some money out of it, and then just save up for a new card. Or you just do the proper thing and solder yourself. He says he is not able to do that. That's a fair point. Like, you might expect me to be that guy that complains about his soldering skills, but my soldering is awful as well. So, yeah. Pretty much what I would do at that point, with the 970 at least. The 7770, I would have to go around with a multimeter and find out what exactly is wrong. I'm suspecting that at least one of the VRMs just isn't running. On the 970, I would just check for shorts and well, pretty much like I have that 970, I have that PCB, I have it E-powered, and it works. Like I replaced the Vcroe VRM with an E-power, and that made the card work again. I didn't have the same issue. I didn't have a major short. The VRM just kind of didn't want to power on, and I never really found out why. I just replaced it, and then it worked again. But yeah, pretty much like, I mean, realistically, you would try to find the shorted MOSFET, then replace that MOSFET, and then the card would probably work again. Or you could just do the, like, just go around the problem essentially and attach an E-power like I did.
But since I don't see any physical signs, we're going to continue on and see what we can do with these two GPUs.
And another thing, yeah, he's about to clean these cards with like multi-purpose spray. I don't really have an issue with that. I was thinking that maybe someone would like expect me to have an issue with that. I don't. I wash my cards. Like when I clean a card, I just wash them in the sink. Which someone might be going off like, what are you doing? No, that's actually fine. Der Bauer made a video about it. You can wash things in the dishwasher, you can wash things with water as long as you dry them properly. So what I do is I use a toothbrush, just like he's about to. I just tap water, I submerge it in water and just like scrub it clean. And then I take a towel, then I dry it, and then I take a hair dryer and dry it even more, and then I put it on a heater for the rest of the day. And then make sure it is really completely dry, because the issue with tap water is there's minerals in them, in that, and if you don't dry it, like if you keep it wet for too long, you can have corrosion, you can have other things happening, you can have things rust that you don't want to have that happen, so you want to dry it properly. What he does here is probably even more effective than what I do, so I don't really have an issue using that cleaning method.
So now these graphics cards are finally clean. We're going to be putting some new thermal paste and just dabbing that quickly on there, a little bit extra, because you want to make sure that the GPU die is always covered fully, so it's not a bad thing.
One little note on the side. I really dislike when people do that with thermal paste. Like, not the amount, it's just you are dealing with a GPU, you don't have an IHS over it like you would have with a CPU. So having the entire die 100% covered is really, really critically important, because if you just have one little piece of the die that's not covered, it will run significantly hotter than the rest of the die and might even break. I really, really dislike when people just put a blob on it and think, well, the heatsink is gonna spread it out, because I've seen it myself, it happened to me, I've seen it happen to others. You're just gonna end up with one corner of the die not being covered properly, and at best you're just gonna have a card that like crashes weirdly because one corner of the die gets too hot and it just behaves weirdly, or at worst you might actually kill a card. Because the part gets just too hot and just burns out, because like you have thermal sensors all over the die, but there's not like you have several of them, but they don't cover every square millimeter of the die perfectly. So if you have one corner that's really hot, the thermal sensor might not detect that and trigger a thermal shutdown. The card might actually die. And I've heard of that happening actually. So I always pre-spread the thermal paste to make sure the die is 100% covered before I put the cooler on. That's just a side note. A lot of people do this, and I really don't like that.
To use a little bit of extra thermal paste in this phase, but also keep in mind that you don't use conductive or capacitive thermal paste. So I found something like MX4 or even off AliExpress GD900 is absolutely fine, especially if you're on a budget. Now, one thing you'll see me do is I'm cleaning, I'll spray the multi-purpose spray on, and since it's an oil-based solution, I then use a little alcohol wipe to clean off that bit on the die, because this has to make contact with the cooler. And I just use my shirt because I'm a little bit of a bogan. In Australia, a bogan is just a bogan. I'll put the Google definition up on the screen here for you guys so you can check that out. And using your shirt to clean things shouldn't be a problem unless, of course, you've just finished maybe cooking some burgers down at Hungry Jack's. I think you guys overseas call it Burger King. If you got a lot of oil on your shirt, then yeah, you might want to change your shirt before you clean the graphics cards. But let's put these things back together, and we're only going to use a little bit, we're going to use 2 screws. So we're going to put this back together and put it in at a diagonal. And the reason I'm doing this is because if the graphics card doesn't work again, then we're going to go to our last resort method. And that isn't, it's like, that's the last resort because it's the last resort. After that, I pretty much just, give these graphics cards away to people who want to have a crack locally at fixing them, as I've got no real need for them anymore. But you'll see here, I'll just quickly put down.
Okay, so he says he's giving the cards away to people locally who want to fix them when he can't do it. I'm not quite sure if he does that before he does what he's about to do to them, or if he doesn't do it usually. People who buy cards off eBay to repair them, who I am one of those, if you are about to sell me a card that has been heat gunned or worse, seen in oven, I would kindly ask to not sell me that card, because people heat gun or put cards into an oven way too often when the issue they have doesn't have anything to do with needing heat, which is actually the case here for at least the 970, but for the 7770 probably as well. When he gets to it, I'm gonna say some more about it, but like, when you sell something on eBay as broken, or like when you think you can't fix it, don't heat gun it. Don't put it in an oven. That just makes the fix even harder, because if it doesn't fix the card, the issue is something else. And when the issue is something else, heat gunning the card just makes the condition worse. Don't do that. Just don't. Yeah. And another thing, he's about to say something like, yeah, you don't need to put the heatsink properly on when you test the card. You don't need to put like the VRM heatsink on it. That's okay to an extent. You don't have to put the VR, like I would put all the screws for the GPU heatsink in. Just using 2 screws instead of 4, the time save of that is inconsequential in my opinion. Not putting the VRM heatsink on, yeah, that's fine, as long as you don't run benchmarks on it. If you just want to see if the card like puts out an image and installs the drivers, that's okay. Don't run benchmarks on cards that do not have their VRM heatsinks installed. Depending on what card it is, it might just shut down safely, or it might experience spontaneous VRM combustion, and at that point, the card you're trying to repair is twice dead, or turbo dead, or dead squared, or whatever. So, yeah, keep that in mind. He didn't really specify a lot, so I wanted to specify.
1 screw on the diagonal, just there, and then another screw on the diagonal. And this is just for testing. So if the graphics card works after this, I can put the whole thing back together and we'll all be good to go. But this part here is a little bit different with the MSI one. Now, I'm leaving this out, especially in this case, because we had power delivery issues. I'm gonna leave this bracket off. And if you've got a back plate as well, I suggest leaving that off for this phase too, because what we wanna see is if we've got a problem with the actual GPU itself. So leaving as much as we can off just for the initial boot phase is going to save us a bit of headache. So hopefully these 2 cards will give out a signal now, and that's fingers crossed. Now also another thing is too, before putting this on the test bench again to test it up, the inputs and outputs on this 7770 here looks absolutely fine. So we're going to leave that one alone. But this one here, you'll notice, if we look at the camera closely, there's a little bit of rust, especially in this HDMI port. So what I'm going to do is...
So yeah, pointing out that is kind of interesting because this might actually tell us why the card is dead. There's not just corrosion on the HDMI there, you can see it's also on the DVI port here. If something rusts, it was probably wet at some point, and electronics and water don't mix. Like, I know I just did a statement about washing things with tap water, but I made a very specific statement about drying it properly. If things are running and they get wet, that's an issue. So maybe that MOSFET didn't just die because they're known to die, and that happens a lot. Maybe this card actually has water damage. Which, if you examine the PCB more closely, you could maybe see corrosion on some of the solder points. There could be water or moisture under some of the chips, like on the underside of the GPU, the memory, or also some of the MOSFETs and VRM components. All this might just be completely... this might also be unrelated. Like maybe the person who had this in their PC just had a very humid room, and the AO being exposed to the room air from the outside more than the rest of the card might have just... the humid air might have just clung a bit to that and caused some rust over time. But this might actually be indication that this card could potentially have water damage. I would of course need the card in hand to verify that, and since he's in Australia and I'm in Germany and he has 500,000 subscribers and I'm just about over 1,000, I don't think I'll ever be getting this card into my hand. Probably also because he's going to destroy the card in the video still. Sorry for spoiling that, but there's going to be a part in this video where the card very obviously dies for good.
Just make this graphics card's HDMI port a little bit happy and start jerking it. And hopefully if that was the issue, then we might have fixed it.
That's not the issue. That's very much not the issue. Like, the port might be damaged, but that's not gonna fix your short circuit.
Now another thing we can do before we put this PCIe finger into the slot is we can check it with a rubber, and if it's corroded or it's showing signs of just maybe a finger's missing or something like that, showing signs of damage, we can try and just rub this rubber over it and just give it a clean. So just rub this finger down and clean it a bit.
That's a very unorthodox method. So when the PCI Express slot looks clean, in my experience, there's nothing wrong with it. Like, if there's issues with the PCI Express interface, there is going to be visual damage. A lot of things that people miss is these little... can I go a bit back a bit? So these little capacitors right next to the PCI Express slot, those are on the PCI Express data lines, and they are for signal integrity. It happens a lot that these get chipped off. So you get a card where one or more of these are missing. And this can cause things from the card not running at 16 lanes and just 8, 4, 2, or 1. Or it might not cause the card to get detected at all. Actually, my 770 Jetstream had this exact issue. It had the very first of those capacitors missing, meaning that the card wasn't detected at all. I put that capacitor back on, which is very small. If it's missing, you might not actually notice it until you're looking for it. It is very small and very much not very visible. Like, you could genuinely just miss that this capacitor is missing. Yeah, I put that back on the 770 Jetstream and it started working again, and that was the entire fix for that card. So yeah, That's like the most common issue related to the PCI Express interface that I've encountered and also seen online.
Finger into the slot is
So let's...
it a bit.
Yeah, we've seen that. Okay, next part. And this is where it happens. You see that? I hope my cursor picks up. You see that? That is the smoke of death. This card is now gone for good. Before I pressed that power button, the card was very likely fixable. Now it is done. Now the card is dead. Now it is essentially scrap metal and replacement parts for the parts that are still good. So I don't think he has the knowledge or is aware that cleaning the board or like putting an HDMI cable into the HDMI interface, that's not fixing a short circuit. A short circuit is a connection somewhere where it shouldn't be. If you clean something, that's not gonna remove that connection. Like, yeah, like it's a major short circuit. If the power supply trips, it's a major short circuit. You can have minor short circuits on the card and the PC will still power on. But if it's a major one and the power supply trips, yeah, you're not removing that by just cleaning the card. And yeah, so I can't really say how his cleaning process affected the card, but before, where the power supply would trip, now it no longer doesn't. Maybe this is a different test bench where he has one of those cheap power supplies that don't turn off fast enough. Maybe it did something other. GPU went up in smoke and find a method. Yeah, you're way past redemption at this point. The card is done. So this is one for the bin, which it is kind of painful for me to watch because I've had that very same PCB with a very similar issue and I got it working. And that was the first time I got a dead card working. That was the very, very first quote-unquote repair I did. It was a very unusual repair which involved an e-power, but still, I got a card working. It wasn't working before, and that was the first time I pulled it off. He already quote-unquote repaired other cards before, and yeah, he botched this one. Yeah. So at the point where you're seeing smoke, especially when you first had a short circuit and then you see smoke, I mean, I would still try to repair the card at this point, but there is like a 99% chance that this is just toast now. The card is essentially destroyed. If it was savable before, now it isn't. The card is gone. And at this point, I would just turn it off as fast as possible. Like, if you see smoke, just turn it off immediately. Don't let it sit like that, because it could actually develop a fire. And this one is still getting stuck on that same postcode, probably because it also has a VRM issue, which can't be fixed by cleaning it.
So we failed miserably 2 out of 2 times there. And look...
You see that thing? I really hope my cursor picks up. The top dual end fed here, that kind of looks like it has a hole in it. And that's kind of where the smoke came from. Like, you see the other dual end feds all have like an even surface, but this kind of looks like it has damage to it. So that kind of supports my theory that one of the Vcroe dual end feds is shorted from 12 volts to ground, because this very much looks like this got hot enough to deform and develop smoke, essentially. Because this looks like this little hole in there looks very similar to that PWM controller I blew up. So I'm pretty sure that this is the shorted MOSFET, and that 12 volts, like, for the time, like, if you saw smoke, there has been enough power going through your short to turn PCB material into smoke. That's a lot of heat. Which meant that the short is probably very, very, like, it's not just a little bit of wire touching where it shouldn't. It's like a big, big power plane be completely dead short. So the GPU core probably like the core just got so much voltage, like especially because he didn't immediately turn it off. Like he left it on for so long. Yeah. The card is destroyed, yeah. And this the 7770 probably just has a VRM that doesn't power on. That could be a relatively easy fix. It really depends. If you have a card that doesn't have one of the VRMs turning on, you really need to have the card in hand and check for yourself to find out what's wrong with it. Which is also why when I get questions from people, I have this and the card won't do, I just don't respond because I can't help. Because there's just no way of me knowing what's wrong with it without having the card in hand. And no, you can ship your cards to me, but that's not the point of the video. The point of the video is this other video. So yeah, let's continue.
At least when you come to TechYesCity, you're going to get straight up transparency. I'm not here to beat you guys around the bush. Unlike, I've seen some tutorials in the past, I'm not going to name which, and it's like, yeah guys, we oven baked 10 GPUs and all 10 of them are working again, and they don't even show you.
To be completely honest, this tutorial very much sounds like that. I don't mean to offend, but this tutorial very much seems like... I don't think it's not a scam tutorial, but it very much sounds like one. I think what he's referring to is that Linus Tech Tips video he made, where he literally put a card in the oven, which did actually end up working because it had one of the issues that's fixable by heat. Yeah, like shenanigans with Louis Rossmann ensued. Like, yeah, like you probably know Louis Rossmann if you watch my channel. So, yeah. Kudos to him for being transparent, for admitting defeat here. But yeah, anything he's done up to this point and will do for the remainder of the video is not gonna bring any of these cards back to life. I'm going to say at the end of the video in which cases the heat gun method is actually working. Because I've pulled it off several times successfully. I've only failed once. So yeah, let's continue.
Show you any proof, and it's like, well, how am I meant to trust some random guy on the internet I've never met before? Like, that's a recipe for success, isn't it? But what we're going to do now is just clean up these GPUs right here. Just going to give them another little quick clean up, especially around the GPU die area where we just put some fresh thermal paste on. And now we're going to get a heat gun, and we are going to bake both of these GPUs for around 5 minutes. And I say 5 minutes this time around because we know the problematic areas. In this case,
So 5 minutes is a lot of time to heat gun a card. I know why he says 5 minutes, which is because he just said he knows the problem areas, but he doesn't know the problem areas, which you're going to see. He actually does something that's legitimately dangerous for his health. But yeah, if you have a heat gun problem card, and now I'm getting into the thing that I want to do at the end of the video, you point the heat gun at the core and maybe the memory chips. Nothing else. You don't point the heat gun anywhere else but the core and the memory chips. You don't, because those are the only parts that can be fixed with a heat gun. Everything else cannot be fixed with a heat gun.
this is the area here. This one of these MOSFETs, I believe, is a little bit faulty, so maybe giving it a heat gun.
Okay, heat gunning a MOSFET is not gonna fix it. Unless there is solder under it that shorted, but I don't know a way where that would happen. What he's pointing at here is the BIOS chip. I don't know what would be wrong with the BIOS chip. If the BIOS chip smokes, then you probably have a bigger problem somewhere else, because it's a BIOS chip. It's just a small flash cell in there. Yeah, that's not a MOSFET, that's the BIOS chip. There is a similar looking IC on the back, which is the PEX rail for the card, which is a linear dropout regulator, I believe. Could be a very small buck controller, a buck converter. I don't specifically know. I just know there's one on the back because, well, I have this same PCB card. This thing is a MOSFET. Like these 6 things, they are dual end FETs. They actually have 2 MOSFETs on each of these chips. Oh, that small thing, that's a typical MOSFET package. Or those things over here. I still hope my cursor's picking up in the video. Those are MOSFETs. That's a BIOS chip. I don't know what would be wrong with the BIOS chip because he didn't multimeter check it.
Some really high temperatures could fix that. In this case, this 7770 right here is...
Okay, so you can see here he's pointing the heat gun not just directly at the MOSFETs, which is not gonna do anything. Like, if a MOSFET is shorted, putting heat into it, which would have happened anyway if you turned it on, because short circuits usually produce a lot of heat because there's a lot of current going through them. Putting more heat into it, that just won't fix it. Like, it just won't. But there's a very big problem right here. And this is one of the major problems I have. He's pointing the heat gun directly at all of these capacitors. It might not have happened to him yet, but it happened to me. If you heat these through-hole can-type capacitors enough, they will explode. And if they explode, not just the cap shoots off somewhere which could hit you somewhere. If it hits you in the eye, you're gonna have a very bad day. If one of those capacitors explodes, it's not just gonna make your room smell like exploded capacitor for 2 days. It will also release legitimately toxic things into your room's atmosphere. You have to vent your room immediately if that happens. It is toxic. Do not inhale exploded capacitor. Do not. Doing this is legitimately dangerous for your health. Do not, never, put a heat gun directly at such an exposed capacitor. Put a bit of aluminum foil over it, and if you watched one of my videos, you will see that actually that's not enough because one of them exploded on me with the aluminum foil on it. Do not do this. Do not point a heat source, like a heat gun, at one of those capacitors. If they explode, you are facing health risks. Do not do this. This is a big problem.
Definitely a scalar issue because the card makes it to the BIOS. So hopefully heat gunning this area on this card and heat gunning this area here can hopefully, fingers crossed, can either get one of these 2 cards
Do not heat
to
gun
get a
these
signal
areas.
back to life.
Do never heat gun these areas. They will either not help, it will either not help, or you might actually get health problems. Also, one thing I didn't say until now is, especially when you do it with the oven, but also with the heat gun, capacitors, again, they hate heat. When you buy a capacitor, you get something like it's rated for X amount of hours at 105 degrees. The hotter capacitors run, the faster they wear out. And the scaling is not linear, like it's exponential. So with more heat, the capacitor wears out exponentially faster. If you heat them to, let's say, 230 degrees, which would be around where lead-free solder melts, yeah, the capacitor is gonna die very, very fast. And if you do it in an oven where you heat the entire card and not just the problem area, that's gonna make it even worse. Which I've actually talked about this in the past. I have a 7970 Lightning that was put in the oven by the previous owner twice. And that card has a very interesting scaling behavior where you give it more voltage and it doesn't scale until at some point where you give it enough voltage, it just scales a whole lot instantly. That looks a lot like, to me, those capacitors are just completely toast. So you just need to raise the voltage so much until the minimum voltage just goes up by you raising the voltage, not because the capacitors are filtering it. So yeah, you can damage the capacitors by heating them. That will probably not kill the card. It will certainly impact overclocking, and it might, if you damage them enough, might not make the card stable at stock speeds. Yeah, probably didn't fix it. And I mean, we know this card is done. Like, there's nothing.
And here we
gonna
are
happen.
now at conclusion time with two graphics cards that didn't work before we came into this, and they still don't work after. But that being said, this is the whole process that I do around TechYesCity from start to finish, and I thought I'd make it all in one video in order to show you guys what I do to give these cards the best chance they have at working again. Now, you may have seen in the final attempt to try and get some life out of these cards, I did put it also in the bottom slot, which is a PCIe 4X slot. So there are things you can try like this.
Using cards on different PCI Express slots, that's actually a legitimate strategy. Sometimes, like, because your main PCI Express slot, your 16X slot, is connected to the CPU, and then your other PCI Express slots, like a second one, is sometimes also connected to the CPU, but the other ones are usually connected to the chipset. And sometimes running graphics cards off of the chipset is better than running it off of the CPU. Sometimes also reducing, like going into the BIOS with a working card, setting your PCI Express speed generation to something lower, and then booting the card that didn't seem to work. I actually had that happen with my GTX 590, where if the BIOS was set to 3.0, it wouldn't post, but if it was set to PCI Express 2.0, which is actually what the card supports and is supposed to run at, then the card works fine. So that is a legitimate strategy. It's not gonna help anything here because we know what the problem of this card is, and it smoked. Like, it produced smoke. Putting it in a different PCI Express slot is not gonna change that. It produced smoke and something burned on the PCB and probably destroyed the GPU core in the process.
To just get some life out of these cards. Though during any of these steps, if you manage to get a signal out of your GPU, but it's a weird signal in that the card still isn't working 100%, say for instance you have some pixelated blocks showing up on your monitor, or there's just weird lines and random patterns going through, then there is one
Okay, hold that frame.
showing up on your
That
monitor,
artifact
or
frame.
there's just weird
I don't think I'll be
lines and random
able to
patterns
pause at the very second where it happens.
going through. Then there is
Oh, there it was. This is one of the cards that's probably fixable with the heat gun. More on that later.
one more thing you can try, or actually two more things, and that is the first thing is to get a program called, download this, it's called Msi Afterburner. I'll put the links in the description below, and then drop your memory and core clocks all the way down, and then save that, and then restart the computer, and that might fix your problem.
That can fix your problem if you have a degraded core. Doing this will obviously cut your speed in. You will probably end up with 10 or 20% of the expected speed. So your card will essentially be so slow it won't be usable anymore, but it might be stable at that point, and then you can like step the core clock up until you reach instability again. But, well, I had cards where, well, I had one card where reducing the memory clock so much, like I had to edit the BIOS because Msi Afterburner wasn't going down far enough, but I had to edit the BIOS, limit the memory clock to 500 megahertz down from 3.5 gigahertz, which basically turned the card, which was a 780 Ti, into a GTX 580. That made the card work again, but it was so slow that just, yeah, I mean, that doesn't really do its job anymore at that point. But yeah, that can make a card stable again, but it doesn't, like, that doesn't fix the problem, it just goes around it. And it might actually get worse over time, because if your core degraded this much, what will stop it from degrading even further? So at some point, even putting it down all the way is not gonna be enough.
If it does, then it just means that your graphics card hardware, more specifically the VRAM or the GPU core, has degraded to the point where it can no longer function at the stock speeds. Another thing you can also try is reflashing the VBIOS.
Reflashing VBIOS can help. Like, usually if your card puts out an image, it's probably not a VBIOS problem, unless the previous owner did some own modifications with the BIOS and messed something up, then sure. But having a corrupt BIOS usually means the card won't post at all. Unless someone flashed a wrong BIOS on it and broke something, then yeah, of course it can like have intermittent issues. But I've never seen a card that had a corrupt BIOS put out an image. So that's kind of a niche scenario, because I don't think many people flash custom BIOSes on their cards and then sell them as broken because they don't know what they're doing. There are probably people like that, but I don't think many. And yeah.
Do have these sort of weird lines and pixelated blocks coming up, and after that you pretty much have to get the card repaired, or you can just give up on it. But there is one cool thing I like to do with the graphics cards after I'm finished with them, if they're still not working, and that is I take the coolers off and I use all these screws for, say, a graphics card in the future that comes in and it might have a broken fan, and then I've got one here that works absolutely fine. So I can then use this one on the broken cooler and then have a card that functions 100%. So that's something that you can still do with cards that aren't functioning properly from the PCB and the GPU itself.
Well, at least he's using some parts of it. Well, yeah, that's a legitimate strategy. Just like, I mean, you killed the card in the video, so it's your right to use it for spare parts. I would have liked it more if you repaired the card. If you at least didn't destroy it more than it already was. But yeah, you can of course use it for spare parts.
Though with that aside, I hope you guys enjoyed this tutorial. If there's any other steps or tricks that you've got of your own and you want to share them, because let's face
Doing that right now.
it, right now, I think a lot of people would just like to play games and they can't afford to because the prices of GPUs have just gone through the roof. And so in this current state, I think there's going to be a lot more people trying to get stuff that didn't work to work again. And so this is just one of those guides that you can follow, and maybe it helps someone out there get a bit of a better gaming experience, especially if they're, for instance, on an old HD graphics CPU from Intel. Then this would definitely help if they could get a card working and play some games. But with that aside, guys, I hope you enjoyed today's video. If you did, then be sure to hit that like button. And with that aside,
okay, yeah, this is just comments and things. So the video is pretty much over at this point. So yeah, I mean, pretty much all my main points I've already made. Now let's get to the part that I've been delaying. So, when is the heat gun method that he's doing here? When does this actually help? So, when you fix a card with a heat gun, you can fix it when it has a FCBGA problem. So, the GPU core, which is just the middle, like the shiny part, it sits on this green PCB, which is the substrate, and same for the NVIDIA card. It's kind of obstructed. Do we have a... Yeah, here. So you can see it sits on this small, like green, bluish PCB. That's the substrate. And the substrate is connected to the main PCB with a BGA, a ball grid array of solder balls. A lot of people think that heat gunning the card reflows that ball grid array. It doesn't. You can look up more specific things in a video that Louis Rossmann made. What you are actually repairing, or more like forcing back into alignment, is the FCBGA, and that's, you might already think, that the connection between the GPU die, the shiny part, and the little PCB, the substrate. It's a similar connection to the BGA between the substrate and the PCB, but it's a lot smaller. And specifically, if you heat shock it, so you go from room temperature up to 220 degrees or something like that very rapidly, you can force misaligned connections in that FCBGA back into alignment. And that can fix the card. Or more like make it working temporarily again, because at some point the problem will come back, because those connections will go out of alignment again over time. And that process gets accelerated by high heat or high power, pretty much just high heat and stress. So if you run your card cool, it probably will live longer after doing this. So when do you have FCBGA damage? Because that's probably a new term for a lot of people. So it's pretty much what causes GPUs that boot up, they put on an image, but they artifact, or they just black screen when you install the driver. That indicates like it's pretty much what a degraded GPU looks like. So it's either so unstable that it artifacts all the time, or it's slightly less unstable and it runs Windows fine with the basic Microsoft Basic Display Adapter driver. But once you install like the NVIDIA AMD driver, the screen just goes black or also artifacts a lot. That's a strong indication that you have this FCBGA damage problem. And heat gunning a card that has these symptoms can fix it. Now, I've bought several cards off eBay with this problem, and I've heat gunned all of them, and all except one card have started working again. None of them have dropped dead again on me yet, though I have to say that I only benchmark my hardware. I don't use it every day in a gaming system, which you might do. So yeah. And potentially there can also be problems with the VRAM, so the memory chips over here. They have a more standard BGA under them, but if you hold a heat gun to them for long enough, you can actually soften the solder balls in that BGA array as well. You usually can't under the GPU because the GPU is thicker. It has more heat mass, like thermal mass. You won't be able to soften all those BGA balls at the same time. But for memory chips, which have less BGA balls and are easier to heat, yeah, you can sometimes heat them as well. Like if the memory chip has BGA problems, then that can fix it as well. When I reflow cards, I just so my method, reflowing is the wrong term, by the way. It's you don't reflow the card, but I just keep saying it even though it's wrong. So when I heat gun a card, my method is I hold the heat gun over the core about 5 to 10 centimeters away for 40 seconds. Then I back off to like 10 to 15 centimeters, and then I just heat the area of the core and the memory continuously. I like go around in a circle shape around the core and VRAM area and just heat it a bit continuously. I don't think the second part is really necessary. I think the 40-second part is already what you need to do. I just keep doing the second part just in case that there's like a BGA problem with the memory chip. And then like in between doing that circle motion, I go like closer to the memory chips individually and heat them for a couple seconds to maybe also fix a BGA problem that the memory chip might have. I just do it anyway on all the cards, so I can't really say which card had which issue. I can just say that all except one have started working again. And actually, no, how many cards have I fixed with this method? Quite a lot. No, I don't have all of them anymore because they became e-powers. So there's a lot of GTX 580s. There's 1, 2, 3, 4, and then there's a fifth GTX 580, which was the one that didn't work. There is one 780 Ti that I heat gunned. There's two 780s that I heat gunned. There is that 7970 Lightning, which I heat gunned and worked again. There is one GTX 480 that I heat gunned and that then worked again. And then there's another GTX 580 that I also heat gunned and then worked again, but that's not mine, that goes to a friend. So yeah, I have used that method a couple times, and all except for that one GTX 580 I succeeded. So I guess that other GTX 580 either didn't do the procedure properly or just didn't have a different issue, like actual damage somewhere else, maybe in the BGA array, which you can't fix with a heat gun. You need a proper rework, like reflow station for that. So yeah. So when you have a card that's artifacting, or when it black screens when you launch or install the driver, those are the cards that are candidates for the heat gun. There's no guarantee they will work again, but there's a high chance they will work again. And I think with that, and with more than 1 hour of recording, I think that's enough for the video. So I hope I brought my points across well. Like, again, I don't mean to be like offensive here or be like, this YouTuber's bad. It's just like, if he sees this video and takes it to heart and learns from it, then that's great. But what I'm more shooting for here is that other people see it and don't get misinformed by this video. Because, like, as I've said, the capacitor thing, there are legitimate health risks, and you can just break the card more than it already is by doing some of these steps, because you don't, like, doing the methods that he does, it is, you never actually know what's wrong with the card. You just do things and hope that they work out, which is a very bad way of doing things. So, yeah. But I think that's really it now. So, thank you all for watching this 1 hour long video. I hope you learned something. I hope you are now smart enough to not do things like this. And yeah, until next time, goodbye.